All right, good morning, everyone. Today we are going to begin practicing some FRQs for our IA the week after spring break, as well as our AP exam that we're going to take this year. So we've practiced FRQs before. We've done this in our floats, and then we've taken FRQ quizzes. So this is hopefully something that's not foreign to you. But we're going to go through each of these. Every day this week we're going to do an FRQ from a previous AP exam, and then in class we'll do one together, just so that we all get more practice with these FRQs, since that is what you'll be graded on your AP exam. So looking at this problem here, this is number 1 from an AP exam. Note that you are looking at some sort of graph, a distribution. That is usually going to be number 1 on every AP exam, so we should expect something like this. The first part here asks us to describe the shape of this distribution. Now, one important thing here is that they're only focusing on the shape. They don't say just describe the distribution. If that were the case, then we know that we would have to include our SOX, which is our shape, outliers, center, and our spread. So I'm actually going to sort of deviate from this problem for just a moment, just so that we can talk about these 4 things, specifically these 3. Hopefully all of us know how to determine an outlier, but mainly I want to focus on what type of measures can we use to describe these 3. So let's go ahead and take some notes on this. Just to refresh here, so the shape can be described in many ways. First, we can either talk about its symmetry, so whether it is skewed right, skewed left, or it is symmetric. No, I do not use the word normal here, because normal would indicate symmetric and unimodal, but symmetric and normal are not synonymous with each other. They are different. So I want to mention one of these 3 things, and remember that the skewedness is dependent on the tail. So where is the tail located? That indicates if it's left or right. So if the tail is on the right, we're skewed right. If the tail is on the left, we're skewed left. The second part of the shape is describing the modes. So we can either be uniform, which is essentially a flat straight across curve. So I think this would be best drawn as a picture here. So it's flat, straight across, there are no modes. Unimodal, meaning there's only one mode, one hump in the graph. So this could look something like this, or that bell shape that we're used to seeing. Both of those would be unimodal distributions. We could be bimodal, indicating that we have 2 modes. So that could look something like this, or something deviating from that, but really the important part here is that we have 2 modes on this graph. And then lastly, we could be multimodal. So this could be, we have 3, 4, 5, however many modes we want to indicate here. But that could be something where we're kind of just a roller coaster going on here. So we could be multimodal, having multiple modes. So that's for the shape. The center mainly focuses on 2 aspects. So this is either the mean or the median. And usually when we're describing the center of a distribution, most times we're going to use the median unless they give us the specific data, and then in which we can calculate the mean. So we know that in the mean, in a symmetric distribution, these 2 are going to be approximately equal to each other. So that is something to note here. And then lastly, our spread. So the spread can be the IQR. So that's equal to Q3 minus Q1. This could be the range, which is equal to the maximum minus the minimum. This could be the standard deviation. Again, if we're given some sort of data set, we could calculate that. Or these two are related to other, or the variance. So the variance is just the standard deviation squared. But those are we would find using our calculator. And standard deviation, we've talked about much more about this year. We know this as the spread of our data. Specifically in the normal distribution, we talk about the standard deviation of our bell curve. Excuse my crude drawing. We know that there are 3 standard deviations away from the mean included in a normal distribution. So we know that already that it talks about the spread. It's something that we really only can measure if we are given the only way that we can say exactly the distinct value of the standard deviation is if we are given the data set. We can only really talk about the standard deviation in relation to the distance away from the mean, if we talk about the mean, that kind of thing. So really, we won't really use the standard deviation that much unless we're given a data set. Okay, so now that we've had a quick refresher on what these are looking for, we can go back to the problem. And we know that they're just focusing on the shape. So I need to talk about one of these items here and one of these items here. So looking at this graph over here, the best way to really view this is if we flip this onto its side. So I can't really do that here on the screen. I don't think I can rotate my paper. Let's see if I can rotate this one. Nope, that's not what I wanted to do. So rotate this. There we go. Okay. So if we look at this here, this gives us a better view of how to determine the shape, because we're used to looking at curves in this manner. So note that I have created this distribution like a normal graph where we have the smaller numbers here on the left, and then we're increasing to the right. So this is the appropriate way to look at a graph. So if this were some reason we started from 9 and then we went down to 6, we would need to flip our paper again to look like something. No, it won't do it. Okay, to look something like it's flipped the other way. So it's counterintuitive, but that's what we're looking at here. So because we're going from 6 to 9, we're good to go. So looking at this distribution here, I see that we really only have one mode going on, and I see that we are skewed. So now I need to be specific with my skewedness and say, which direction are we skewed? Well, I see that the tail of my data is to the left, so we are skewed left. And then again, since we only have one mode, this is unimodal. So let's go ahead and flip our paper back. And so for part A here, we can say the distribution, or let's be more specific, the shape of the distribution is skewed left and unimodal. Okay, so part B says, in order to motivate her students, the instructor of the class wants to report that overall the class's performance on the exam was high. Which summary statistic, the mean or the median, should the instructor use to report the overall exam performance was high? Okay, so we talked about this in the beginning of the year, but notice that they want to talk about essentially the center of our data here, right? They say the mean or the median. As we noted before, those two are our measures of center. So if I look at this graph, we've already determined that this is skewed left. So if I were to use the mean of my data set, that is going to be essentially pushed over towards our tail. So we would think that, well, the mean's going to be at the highest point. Not necessarily, because we have this data that's pushing or pulling our mean towards our tail in a skew distribution. Our mean isn't going to be necessarily representative. So if we have a skewed distribution, we want to use the median in order to determine the center of our data. So we can say, since the distribution is skewed left, the mean is pulled towards the tail. So the median would be the best report to use. Okay. So now, part C, it says the mid-range is defined as the maximum plus the minimum divided by 2. So we're essentially averaging out our tail points. So we took the maximum value, which is located here. We don't necessarily know what that number is. We know it's in the 90s, but we don't know exactly what it is. But we know it's going to be there. Then we take the minimum value here. Again, we don't know exactly what it is, but we know it's going to be in the 60s. And then we average that out. So if I take the maximum number and I take the minimum number and I add those together and divide by 2, it's probably going to give us somewhere in here, some number in between. So they're wanting to know, is the mid-range considered a measure of center or a measure of spread? So looking at this data, if I were to compute the mid-range in this problem, let's say we have 98 is our maximum here, and our minimum is 62. And then if we divide that by 2, let's see, we get 160 divided by 2 gives us 80. So like I said, somewhere in that range is going to be the mid-range. So we need to think to ourselves, okay, is this number going to tell us how spread out our data is, or is this going to tell us where our center is located? Well, if I look at what value this gives me, it looks like it's pretty much in the center, and that's exactly what the mid-range is going to tell me. It's a measure of center. This might be counterintuitive because it has the word range in it, and we discussed on the page here that the range is a measure of spread and the interquartile range is a measure of spread. But you have to think about the fact that this is giving us the middle value. Both of these here, if we take the max minus the min, that's going to tell us, how spread out our data is. It's going to tell us, where is our data starting and where is it stopping, and is the maximum close to the minimum, and in that, is the range closer to 0? Is the range closer to 100? Similarly to the IQR, is the IQR closer to 100 or is it closer to 0? But here, if I look at this, and if I add these two together, I'm not subtracting the minimum and the maximum. I'm adding them together, and then I'm dividing by 2. So that makes me think when I divide numbers, I'm really kind of getting a sort of average here, a mean, and we know that that is a measure of center. So when we take the mid-range We're not subtracting it like we do with the IQR. We subtract, nor the maximum, we subtract. We are adding and we are dividing by 2. So this is more like a mean rather than a range. So for that reason, this is a measure of center. So we can say that the maximum is sort of our upper tail. Our minimum is our lower tail. So when we average these two values, we are getting a halfway point, which is a measure of center. So let's write that down. You can say that this is the upper tail and the min is the lower tail. Let's continue on to another page here. So this is continuation of part C. So the max is the upper tail, the min is the lower tail. So averaging these values together gives us a halfway point of the data, which is a measure of center. Okay, so looking at this here, we have essentially named all of the pieces of describing a distribution. We started with the shape. We described the center here with the median. Well, I guess we didn't measure spread. But this is something that you might expect on an AP exam. They're asking you to apply information, not necessarily sort of regurgitate what you've been taught. So parts B and C are really the application of what you know about, the center of your data, where part A is just kind of asking you to regurgitate. It's really just saying, do you know the definition of a shape of distribution? Can you name it? And then the other two parts are really the application. So it requires a lot of thinking, which all of you are capable of doing. You just need to take your time, read carefully, and use your logic skills to indicate, is this a measure of center? Is it spread? What's really going on here? So please join me on the Zoom call at 8:20. We're going to do an FRQ together. So this is going to be part of your classwork. So it's in your best interest, and in your grade book, it will indicate if you've joined the Zoom call or not. So please make sure you are doing that each day. All right, have a great rest of your day, everyone.